There was an Australian postdoc in the laboratory called Lance Black, and Stephen Morbarth went off on holiday and said, can you analyse Gregor's samples? For every sample which turns out to be very old, I'll give you a bottle of wine. So anyway, Stephen Morbarth came back from holiday, and I can't remember how many samples, maybe 8. And Morbarth says to Lance Black, "How many bottles of wine do I owe you?" And he said 8.
Welcome to Polar Podcasts, where you'll hear stories from geologists who've spent their careers, their lives, exploring and studying the remarkable and remote geology of Greenland. Why did they become fascinated with Greenland? What were the problems and the discoveries that drove them? And what was it like working in these remote places where few people venture, even now? I'm Julie Hollis. In this episode, we hear more from Allen Nutman, Professor of Geology at the University of Wollongong in Australia, about his work on dating some of the oldest rocks in the world in the Isua Supracrustal belt close to the inland ice in the Nuuk region.
One thing which is particularly important in geology is to actually know the age of a rock. And exactly the same thing for a historian. They want to know when a particular event occurred relative to another event. So in exactly the same way, geologists want to try and know the actual absolute age of a rock, when it was formed. Also, they want to be able to, if possible, work out the actual absolute ages of some of the things that have happened to that rock since it was first formed. So in the 70s and 80s, this was an extremely specialized field to be able to obtain ages of rocks. Also, it needed large amounts of material. It needed very definite assumptions about the samples. You were doing something called zircon dating. Zircon is a mineral which takes in uranium, which of course then decays to lead. So these little crystals actually act as a little chronometer in the rock. So in the old days, that kind of dating would be done by literally a handful of specialist people around the world. You would have to collect a very big sample. That very specialist analyst would collect maybe something like 50 milligrams of zircon out of that rock. They would have to, at any one time, analyze together thousands of those little crystals that have come out of the rock. Nowadays, the technology is where you can actually get dates on individual growth rings of those crystals. So one's not only just simply dating a single crystal, you can actually see within the crystal growth zones which have developed at different geological events, and on the scale of 20 microns. 20 microns is something like a 50th of a millimetre.
Similar to or thinner than the width of a human hair.
That kind of scale, you can obtain individual ages. So it's like looking at the growth of a tree, where you have different growth rings. Of course, those growth rings have occurred in different years. The same way, if you look at a zircon crystal, the different growth zones in it refer to events millions or tens of millions or even hundreds of millions of years apart. So there has been just unimaginable changes in the technologies involved, not only in the scale that you can analyze things, but also because of the development of the technologies, the vast amounts of data that are now produced annually around the world on the age of geological samples. So, for example, in the 1970s, from the Nuuk region, you might be lucky if there would be the age of one rock by the zircon method would be published a year. Nowadays, people could produce that age literally something like 3 or 4 hours analytical session. So there is this explosion of data regarding the age and history of the rocks, which of course have greatly improved our understanding of the events throughout not only the Nuuk region, but anywhere in Greenland. So with these technologies, they are a lot more user-friendly. So the early technologies, it was done by geochemists. They were specialist chemists who were interested in geological problems. They generally had no knowledge of field geology at all. So the program of dating was done by some collaboration between a geologist and a laboratory geochemist, and there had to be a trust and understanding of a geochemist that the geologist actually knew what he was collecting. Nowadays, because a lot of the technology is so much easier to handle for the dating or other analysis of rocks, the actual geologists themselves can undertake the laboratory work as well. So as a second part of my, shall we say, existence, besides having a very strong focus on the field geology and the mapping, my other speciality is dating of geological events by using the zircon crystals. I have had more than 30 years experience of this using a particular instrument which has got an acronym SHRIMP,
which stands for Sensitive High Resolution Iron Microprobe.
When I have guest people coming to work with me to do this zircon dating with shrimp, quite literally, once I've got the machine set up and in a stable operational state, they can actually be doing analysis with 15 minutes tuition. As my ex-boss, who is actually one of the inventors of shrimp, said, even a trained monkey can run shrimp. So this actually led to a proliferation of all sorts of stuffed monkeys in the lab. And even people say, then sometimes they'll say, oh, I'm not going to do some shrimp work. They say they're going to do some chimp work. So it has been an amazing change in the technologies. Part of it has been strongly driven by two fields. One is nuclear power and nuclear weapons. The other thing, big spin-off, of course, was the Apollo program, in that vast amounts of money were being spent on getting people to the moon and bring rocks back from the moon. And a spin-off from that was the enhancement of all the analytical technologies in order to get much more valuable and worthwhile information from the rocks that had come back from the moon. At that time, the Earth Sciences in Australian National University, the Research School of Earth Sciences,
where Allen was based when he first moved to Australia,
did have a heavy engagement in the lunar program. At that stage, shrimp was still being developed and built, but the very early stages of ANU's engagement in lunar work.
ANU is an acronym for the Australian National University.
Was actually on these funny spherules of glass, what are called impact spherules, which were dusted over the moon's surface, you see. So one technician in ANU actually had the job in, of course, special sterile conditions to sort them out into sort of different categories, appearances, before doing various analysis on them. And another technician told the guy who was doing it that there was still some concern about whether there was maybe some microbial life on the moon, which might have actually be transferred back to Earth, and therefore people who are actually handling and working with lunar material had to be very carefully monitored. And he said that the American embassy in Canberra requires you to take a urine sample every day, and then after 2 weeks you should take your urine samples to the American embassy. So this guy dutifully got all his urine samples and then went to the American embassy, and it was only then when he discovered he had been fooled. He turned up at the American embassy with these bottles of urine and said, "Here they are." And they say, "What's all this about?" And I remember having a practical joke played on me just after I arrived in the dating laboratory, because I had actually brought with me some rocks from Greenland to do some work on shrimp. There had already been a few samples dated by Professor Compston and also a guy called Peter Kinney, but I wanted to expand the program. The samples did arrive. They've been, of course, opened by customs and so on. And Ian Williams, who's one of the, I guess, gurus of that analytical technology, wanted to play a little joke on me. So he said, okay, yeah, they've been opened and they've been actually been sprayed with a compound to really sterilize them. The only trouble is this compound in them has got some lead, you see. And of course, lead is something you have to worry about when dating things by the uranium-lead method. He could see this look of concern and anxiety come across my face, and he said, don't worry, one can very easily deal with it. This stuff breaks down in ultraviolet light, you see. And he said, all you have to do is put your samples out in the garden and every day turn them and so on. And then after that, after a few days, you can just, wash the samples off and then everything will be all right. And so, of course, I dutifully took these Greenland samples home, put them out in the bright Aussie sunlight, you see, and was dutifully turning them for a few days. And then he relented and said, I was playing a joke on you. So as we're on the subject of dating rocks, there's something very special for the Nuuk area, and that is the very old rocks which do occur in the Nuuk area. These were discovered by a synergy between Vic McGregor and some people in the Oxford Isotope Laboratory. On the basis of field relationships, Vic McGregor came up with the idea that some particular sort of rocks were actually much older than the other rocks generally in the region. And he was very keen to have what we call absolute, in other words, radiometric ages, presented on these rocks. However, the laboratory which the Greenland Survey was collaborating with at that time, the Oxford Isotope Laboratory, were not particularly keen on taking these wildcard samples to date, of course, because of the reason in those days it was a lengthy and therefore expensive to date samples. But there was one geologist in the Greenland Survey, somebody called David Bridgewater, who actually thought that Vic McGregor had a good case and brokered a deal with the Oxford Isotope Laboratory, with a chief person there being Stephen Morbarth, who died in 2018, that as a proviso of Stephen Morbarth having some particular samples he wanted to date, he had to date Vic McGregor's samples as well. So that was the deal. So the samples went over to Oxford. But Stephen Morbarth was still not really keen on dating these things. So at the time, there was an Australian postdoc in the laboratory called Lance Black, and Stephen Morbarth went off on holiday and said, while you're away, can you analyse McGregor's samples, okay? And he said, for every sample which turns out to be very old, I'll give you a bottle of wine. Because he was absolutely convinced that he would come back and not have to give any bottles of wine. So anyway, Stephen Morbarth came back from holiday. I can't remember how many samples there were, maybe 8. And Morbarth says to Lance Black, how many bottles of wine do I owe you? And he said 8. So that's how it was actually realised there were these extremely old rocks in the Nuuk Isua area. And to give Stephen Morbarth his credit, he swallowed his pride after this and got very fully engaged and obviously championed a lot of further work in the area throughout the 70s and 80s and also into the 90s. I arrived in Australia carrying a rock bucket full of some rocks that Clark, Vic and myself had collected in that 1988 field season, with the idea that eventually I'll be able to date some of them by the shrimp iron microprobe, because I was joining the iron microprobe group in Australian National University. However, I bided my time because it was made completely clear to me that my first brief was going to be working on the Narian Ice Complex in Western Australia, which contain rocks very similar in character and in age to the Isochron, as they were then known, in the Nuuk region. So therefore, I realised it was not a good thing to start pestering my new boss to start dating Greenland rocks immediately. It was about a year and a half until I broached the subject with Bill Compston as to, whether it'd be possible to actually, do some Greenland rocks. And I think he could see that I'd been a good boy and, it wasn't an unreasonable thing. So he said yes. So I started a small project of looking at some of the rocks that we'd brought or collected in 1988. And the first one I did was something which then became a very infamous sample, which was G8866, which was a bit of banded gneiss right up against the supracrustal unit on Achilea Island.
Supracrustal rocks are rocks that were originally formed on the surface of the Earth, including sedimentary and volcanic rocks.
And at that stage, the oldest rock in Greenland was about 3.82 gigayears.
That's 3,820 million years old, which is about 85% of the age of the Earth.
And then just complete fluke, this first sample I started working on, it started coming out at 3.87.
That is 3,870 million years old.
And on the basis of the field relations, it could be argued very well that the Achilea Association, amphibolites and banded iron formation,
that is, the supracrustal rocks that Allen referred to earlier, interpreted as sedimentary and volcanic rocks,
had to be older than that. This immediately started to cause great consternation amongst some people, particularly the Oxford group, who essentially had the idea that nearly all of the early Archean rocks in Greenland,
that is, rocks older than 3,600 million years,
were very close to the similar age, and there wasn't this spread of ages now of over 200 million years. But that was a debate which reached its head a few years later. So anyway, that was very encouraging and interesting. And then I actually got Australian National University funding to come back in Greenland in 1991 in order to do some more fieldwork, more collecting, specifically for a larger dating program. And of course, that was done with close collaboration with Vic and with Clark Friend. Also along on that trip was Peter Kinney. Peter Kinney is an Australian geologist. He had done a little bit of shrimp work as part of his PhD thesis very soon after the first shrimp instrument was built. At that stage, the only sample dated from Isua by the shrimp zircon method was a unit generally interpreted as volcanics, and that had come out at 3,800 million years. And that was then regarded as a good approximation of the age of a whole of the Isua supracrustal belt. But on that trip, we actually collected from another big unit of felsic volcanic rocks up by the inland ice. And when we started to do the dating, things didn't turn out as expected. I had expected that what we were going to do at Isua with more shrimp work was to refine a chronology around about 3,800, that one would start to take a provisional stratigraphy.
That is, an understanding of how the rocks were arranged as layers, originally deposited one on top of the other,
perhaps differing by a few million years or 10 million years apart in that stratigraphy, in the same way that one can see within the Pilbara greenstone belt successions.
Also a very old area of rocks in Western Australia.
Or some of the Barberton ones, for example.
In South Africa.
Instead, the first sample which I did from Isua again came out as a shock, because it was a felsic volcanic rock which was 3,700. 100 million years different from the first one. And one suddenly started to realise, Isua is a lot more complicated than people think. And on the basis of the tectonostratigraphic terrain model that we've been working on, one started to think maybe there's some fundamental tectonic division within Isua. That was one idea. Another idea is that you might have a 3.8 sequence.
That is, a group of rocks 3,800 million years old.
And then rocks 100 million years younger on top of that. So that was the nature of this first round of shrimp work. Often every single one was a surprise. So those were the really early exciting days when you're getting lots and lots of surprises. But overall, this new model of terrains was actually holding. So with new visions of the complexity of early Archean crust and Archean crust in general in Greenland, my then boss, Bill Compston, decided it was worth throwing more money this way, even though he had this very special terminology for working out of Australia, and that was working on faraway places with unpronounceable names. So that's where we went. We came to a faraway as possible place with as unpronounceable as possible names. And in 1993 came up again, supported by the Australian National University. I was joined by another very long-term collaborator, Vicky Bennett. So Vicky Bennett is now head of geochemistry in Australian National University, and she's also president of the Geochemical Society. So we spent summer of 1993 starting off actually at Isua. So that was the first time actually returned and camped in Isua since the early 80s when I've been doing contract mapping with the Greenland survey. And it was actually quite interesting because at that time, for a very short fleeting time in Greenland history, there was a float plane in Nuuk. So we actually went up on a float plane to Isua and one landed on one of the big lakes there. That was fantastic. We actually started going over in a slower, more methodical fashion in eyes which were many years older than when I first went there. One had under one's belt a lot more years' experience as a geologist. So we were able to reinforce the idea that there were definitely two sequences present in Isua, about 100 million years difference in age. So one lot is 3,700 approximately, one lot's about 3,800, whereas if you do regional whole rock isochrons on Isua,
the Isochron method is a method of dating rocks that effectively averages the result from a range of different samples to calculate a single age. The method assumes that all the samples have the same age.
You get something about 3,750 plus or minus a big error. So in other words, they were averaging the two completely unrelated groups of rocks. So to give you an idea of a game changer in the precision of the rocks, those isochrons usually had errors of about 300 million years, which is from now back to the end of the Carboniferous.
About 50 million years before dinosaurs first appeared on Earth.
To put it into a more modern context. On the other hand, with the shrimp, one was regularly churning out ages which were plus or minus 5 million years. So it was a complete game changer, and that one could be really sure, yes, here we have a bunch of rocks which are 3,700, here they're 3,800, and also we were getting more and more convinced that the break between the sequences wasn't a unconformity stratigraphic break, it was a tectonic break.
By which Allen means it wasn't just a period of time where no sediments or volcanic rocks were deposited on top of the older rocks. These were completely unrelated rocks that had been pushed together by plate tectonic processes well after they formed.
But at that stage we were not brave enough to actually put that in print.
I'm Julie Hollis, and you've been listening to Polar Podcasts. In the next episode, we hear more from Emeritus Professor Brian Upton about his expeditions to Northeast and North Greenland.